So let's get started. So the agenda for today's discussion or today's lecture on QCS is just to introduce you to a tool called QCS, which we are using for our RF topics. So these are the agenda for today. So I would like to cover the introduction part of QCS tool, then some specific application of QCS where we use is for microstrip uh, related discussions or the design. So there I would like to cover some more things, then some examples on what we have done at our end, and finally there is a demo we have planned. So let me jump into the introduction part. So QCS is just a normal free software tool, but it's very simple one and you can easily get started with that. So with that, it's becomes more effective, and I would recommend to anyone who would like to try this out. Previously, I made a video on LT Spice. It's similar to that only, but here we have so many options and specific to RF application is what I feel. I may be wrong, but this is what I feel. And QCS stands for Quite Universal Circuit Simulator, and it's almost 20 years old now, and it can be installed in any of these in any of these applications like Windows, Linux, or Mac or something. And here is the link to download this software. With that, there are a few more slides on the introduction part to QCS simulator, but I will skip these two slides. Maybe you can pause the video and refer to these details later. Then directly, let me jump on to one specific application for which we use QCS is for designing Microstrip. So Microstrip, what is Microstrip? Let me get started with that part. So Microstrip is, as the name suggests, is strip of some conductor placed over a dielectric. And we do play with something called as magnetic field and also electric field. So that's the background on the Microstrip part. And we use this Microstrip as a transmission line and also as a filter as also. Like in few of the slides, we will discuss on that part as well, where we designed the Microstrip and bandpass filter using Microstrip. I mean, yeah, we'll cover that part. And also some of the applications are captured here. So it can be used as a transmission line, and it is flexible enough to propagate the wave from one end to the other end. And also it can be more useful if you go for RF application as such. Then here is an example where the Microstrip is designed on a PCB. PCB stands for printed circuit board, where we can design something and we can stripe, in fact. So some of the sections are explained here on top of this screen, where it started with impedance matching network with some specifications here, and that it will look something like this on the printed circuit board. And then passive amplifier, so power amplifier, and that is here. Then filter is here. Then finally we have some connector, which will take out the connection out. Something like that. And this example, I think, will give some more clarity on what we are trying to say here. I have one more slide which will give some more clarity on this. So here is one more example. Again, I have taken this reference from net, where you can refer to this YouTube video where he will design, in fact, on the fly with respect to a microstrip on a PCB. So the yellow sheet that you see here is the PCB that he has taken, and the stripes that you see, the plus mark that you see, are my microstrips that he has kept. And this video was very good. You can refer to this video and learn so many things from here. So as we mentioned, so we have an input, big signal input is applied here, and the output is connected, or the oscilloscope is connected, and we can look at the waveform, how it behaves. So here, these lines will indicate some specific lumped components, and let me talk about that part. So whatever you see at the start, we can assume that as an inductor of some specific value, and whatever we see as a vertical line here can be assumed as a capacitor. And again, that capacitor other end is connected to ground because again, I'm assuming this PCB is grounded. That's why. Then after that, again, we have a straight line that I can assume that as an inductor. Then again, a capacitor, inductor, capacitor, and inductor, and finally output is connected over there. So input to output connections look something like this. And this simple application can be simulated, and he has done that, and the response looks something like this. So it's a simple example here, and we can try this out also. And we do see something called as S parameter. I will cover that part as well in this in next slides. So S parameter is one of the important parameter that we refer to in two-port networks or multi-port also. But here we are talking mainly with respect to two-port, where S21 or S11 or some names that we use will refer to some coefficients. So S11, S22, point set reflection coefficient, S21 or S12, point set transmission coefficient. That's it. No more than that. And again, as we said, we have two port here to start with. We have port 1, port 2, and S11 talks about the reflection happening at the input side, or assuming input is at port 1. So then we have a transmission line. Then after that, we have S22. So even that can say that output part is covered there. Again, please make sure you understand the naming convention here. So S21 stands for the first suffix, I mean, 2 stands for the output port and 1 stands for the input port. Even that is important here. And again, some more explanations are given here. We can refer to this later. Then in QCS, there is one more very cool option that we see. That is, you can directly go for the calculation of the values like W and length of your microstrip. So here is the second column. So again, I'm talking about microstrip line here, and WL are indicated here, how it is measured and all. Substrate parameter is what we are interested in initially to start with, like epsilon or the height, width, and thickness and everything are covered here. Then W and L value of the specification that we have is for the third column, sorry, is pointing at the L and W of this type that I have on top of the dielectric substrate. That is length and width in millimeter are these values. And this can be tweaked to achieve some specific Z0 value. Z0 stands for transfer characteristic here. And yeah, transfer characteristic of the medium, I can say. So here the medium points to the microstrip line. That's it. So this is very simple, and again I can operate at some specific frequency of operation also here. That is 1 gigahertz is what we targeted. Once you input this value, you can directly export that onto the schematic. So you don't have to worry about again connecting everything manually. Tool will do that for you. So that's the unique feature that I see in this tool. Yeah, I will give a demo on that as well. Here is one example where we designed a bandpass filter, and the frequency response is plotted here from 500 megahertz to 1200 megahertz. Again, these values that we see are tweaked with respect to, let's say, width and length of the microstrip here, and the S parameters are captured here and substrate parameters are captured here. And what we used is something called as Chebyshev filter, and the impedance matching and the frequency of operation are captured here. Yep. Then there is one more example where we use the microstrip line as a transmission line, and the S parameters are plotted here. So we have 4 parameters that we mentioned before are captured here with respect to frequency. So S11, S12, S21, and S22 are plotted for a simple transmission line characteristic. And the start and stop values are captured here, and the points also. So let me quickly jump onto the demo part, and let's see how we can get something from there. So this is how the window looks like, the QCS window looks like. And here you have tabs on the left part of our screen. So you can directly go to components, you can go to libraries and check what are all the available things. Mostly I will be playing only here on the components. I will be looking at some lumped components like resistor, capacitor, inductor, whatever. Then you can go for drop down. Under simulations, you can choose whatever simulations you want, DC, AC, transient, whatever. Then we have components also. Directly you can choose NAND or and something. Those sort of components also available. And there are so many plenty of options that you can see. And micro transmission line is what we mentioned before. And with respect to transmission line, we have microstrip captured here. And also there is some more variants on that that is called as coupled microstrip. Sorry, microstrip. So let me get started with a simple design of a voltage divider, right? So let me go to lumped component. Let me choose a resistor, put it here, put it here, press Control R to rotate this. So rotate it again, rotated. Then just simply connect that using wire. So on top of our screen, we see a option called as wire here. Just click on that and connect them like this. It's similar to any other tool that we use. Even LT Spice will have similar option. Yeah. So let me connect this quickly. Then let me go to sources. Let me choose a DC component of 1 volt. Then let me connect like this. Then let me ground it properly. Then let me label. So in order to label, just go to wire label, this option. Then click on this part and say out. Yes, and done. Then press Control S. If you say Control S, it will ask you where you want to save this. So I may choose some folder. Maybe I can go to downloads under test QUCS. I can save it as maybe test1 is also fine. Test1, then save it. Then don't forget to choose this simulation option that you want. So simulation, under simulations tab, I will go to transient. Just if you click on that, a that will come automatically in your cursor. Just click on that and it will come automatically, and start and stop time are captured here. You can play with that. If you want to play with that, just right click on that, edit property. You can play with these values, start, stop, how many steps you want and all. Then just say Control S to save this. Then the next part is just to simulate. That's it. Yep. And yep, if you say simulate, if after going to simulations and simulate, or just press F2, a new window will come up. And if you don't like to put your results over here, just close this window, go back to your diagrams. There are plenty of options available here. And one of the options that I prefer is Cartesian. Just click on that. Again, this will come up. Just click on that window. And here you'll get the options like what do you want to plot. So you can plot output, because output port is what I'm interested in. So I just click on that, double click on that, in fact. So that should come under graph tab, then say OK. So here is my output. So I've applied a voltage of 1 volts, and at the output I'm seeing 0.5 because I have placed 50 ohms on top and 50 ohms at the bottom. That's it. It's simple. This is done. Let me go to the last demo on the microstrip design. I think here you will feel good, I guess. So again, I selected file, new. So a new file, open new schematic window opened here. Then go to tools, then go to line calculator. Here is an cool option that we have. So again, I selected microstrip line here. You can choose other things also. Under microstrip lines, we have WL, height, and thickness also. I've filled in these values. Maybe by default, it may give some different value. I filled in the epsilon naught to be 4.8. So, and some other values also filled in here. And I was targeting Z naught to be 220. That's why I see this value. And I want this to be operating at 1 gigahertz. That's it. So let's assume this is what I want. Then after giving these values, you can tweak here also. And if you have any doubt, just go to analyze here. If you analyze, you'll get to know whether this will work or not. This W and L and this epsilon value and this Z naught will match or not. Or if you want to pick something, you can pick that also. And we'll get some calculated results here. So even you can do synthesis also. That's not a problem. Then go to execute, then copy to clipboard. So it got copied. Then come here, come on to your schematic window, right click, then paste. So you'll get the elements that you want. Just click on that and yep, press Ctrl S. Again, go to some location where you want to save this. Let me call it as test 3. Yeah, then here is it. Okay, I forgot to do simulation, sorry. So let me do simulate. So I'll get the new window here. Then let me close that. I want to plot everything here itself. Then again go to Cartesian, click on that. Here is the parameter that I want. So I have all my 4 S parameters, S11, S12, S21, S22. Just double click on that, say okay, you got S11. Again, click on that, drop down S12. Here is S12, then something like that. So this is how it goes. So this is the simplest thing that we can see. And also there is one more option, and similar to the calculation option, go to tools, go to filter synthesis. Here also you can choose whatever filter you want directly, like you want low pass filter, band pass filter, high pass filter, whatever. Let me choose high pass filter. Then let me choose Chebyshev, and what is the order you want. Then some parameters also you can choose. Then say calculate for me. If the parameters looks okay, it will give the results to be successful. Then you can say it got copied already. You can take a new window again. So file new, right click, paste it. You have the design, circuit design for you. You don't have to stitch these things like L, C. You don't have to worry about that. Directly you got the answer. Just plot it and see whether it will work for you or not. So that's all I had. And thanks for